This question is asking, some sodium chloride was found to be contaminated with copper 2 oxide. Describe how a sample of sodium chloride could be separated from the mixture. Now this question comes from the first topic in Form 1, and is the topic of simple classification of substance, and the subunit is the separation of mixtures. Separation of mixtures. Now in this topic there are three things that I want you student to note, in order to just be very confident to answer any question from this topic. Now the first thing is that you have to know what is a mixture. Okay, so you'll define what a mixture is. So we do say that a mixture is any substance that is made up of two or more kinds of matter. Okay, that's the first thing you have to know. You have to know what is the definition of a mixture. Now the second thing you have to know is that you have to know what are the variety of mixtures that can be found. Okay, now we have several we have quite a number of them. Okay, so we'll just give a broad classification. So we can have liquid is whereby you have a liquid that is mixed with another liquid. For example, when you have something like water that has mixed with kerosene, okay, or milk that has mixed with water. Okay, so those are some of the things that those are kinds of liquid mixtures you can have. Now in liquid mixtures, you need to know that there is also there's a quality that you have to know. That is are they miscible or immiscible? Okay, so what is miscible? Miscible is that they can mix fully together. Immiscible, they do not mix fully together. Like when you look at kerosene and water, when you have this mixture, you'll find that below here you may have one substance, and there's a clear separation between the two substances. Okay, so here you may have another substance. So these are immiscible. Okay, but when you look at, for example, milk and water, you cannot, when you look at the mixture of milk and water, you cannot say that this is milk and this is water. So we say that they are miscible. So we have liquid. We also have solid. So for example, in this case we have sodium chloride and copper 2 oxide. Those are solid. And the last we have liquid solid. Okay, so for example, when you have a mixture of sand and water, okay, that's a liquid and a solid. Now the last thing you have to note in this topic, which you have to know as a student, is you have to know the methods that are applied in mixtures, in separation of mixtures. So what are some of the methods that you will use? Okay, this is the last thing that you have to note. So we have several kinds of methods which we cannot discuss about all of them in this one setting, but you need to know what is evaporation. Okay, what is filtration, distillation, sublimation, chromatography, etc. and etc. Now what determines the method of separating this mixture? What is the most important thing when you're looking at how to separate mixture? The most important thing is to know the physical property of the components in a mixture. Okay, so what are the physical properties of these components that are in a mixture? So this is the most important thing. The most important thing that you need to know is the physical property. Now let's look at this question that we've been given so far. So in this question you are supposed to separate sodium chloride from copper 2 oxide. Now the key thing, as we said just a few seconds ago, is you have to know the properties. In fact, let me just highlight that in a different color. So you have to know what are the properties of these components that we are talking about. So what is the characteristic of sodium, yeah, that is different from copper 2 oxide? Or of course they are both solids, okay, but what is the unique about sodium chloride that copper 2 oxide does not have? Now if you've read this, you will be knowing by now is that sodium chloride is soluble in water, yet copper 2 oxide is not soluble in water. Now having known that, that will now become the basis of answering this question. So the first thing you need to do is to add water onto the mixture. So you add water. So once you add water, you stir. So what will happen in this case? Sodium chloride will mix or will dissolve in water, and it will leave behind copper 2 oxide, okay, as the solid that will be remaining behind, okay. So that is number one. So the second thing you do is you do what is called filtration. I'll describe more filtration in a few minutes time. So the second thing you'll do is filtration, and what will remain behind is copper 2 oxide, and what you'll get is called a filtrate, okay, a filtrate. So this filtrate will be is made up of sodium chloride and water, okay. So you have to now try and separate sodium chloride from water. So how do you separate sodium chloride? That's now the filtrate that you've gotten. And how do you separate sodium chloride and water? So if you know this, you know what is the property of sodium chloride that's different from water. Now what you know is that when you heat this combination, okay, or this combination, water will evaporate, okay. So the last thing you have to do is to do something called evaporation. So in this case, you evaporate, you heat the this mixture to dryness, okay. So you'll get a dry sodium chloride, and water will have escaped as water vapor. So that is the process of evaporation. So three things that you'll do: add water and stir, do filtration, and whatever you obtain, do evaporation, and you'll get a dry sodium chloride. Now I'll like to end this this revision by just showing you an animation that describes the process of filtration. So what is filtration in this case? So so in filtration, the first thing you do is that you take a filter paper, okay, then you fold that filter paper into four, then you create a cone, as you can see there, okay. The next is that you put a funnel on a stand. Then you remember you had created that cone, you come and put that cone of filter paper on the funnel. Now this is dirty water, so that the dirty water is made up of mud, and so it's muddy water, and I want to get clear water out of this, and I'm assuming I want to drink this water. So I'll pour muddy water through the filter paper, which I've placed in the funnel, okay. So what will just observe that, okay, just observe that what will remain behind is a residue which is mud. And what we'll collect here is you can as you can see very well here we have now clear water. Okay, now this clear water that we've obtained from the muddy water, this clear water that we have obtained from muddy water is called a filtrate. Okay, is called a filtrate. So this is the clear water that we've obtained from the muddy water. Now this method of purifying water is called filtration. Okay, so that's the take-home message. I've just described and given you a clear animation on how the process of filtration works.